Now in this video we are going to take up one more problem on development of lateral surfaces of solids. How to solve this problem by using the solidity software. The problem reads as a frustum of a square pyramid has its base 40 mm sides, top 16 mm sides and height 60 mm. Its axis is vertical and a side of its base is parallel to VP. Draw the projections of the frustum and show the development of the lateral surfaces of it. So this is the problem. First we will go for the solid screen, and first we will go, this is the default solid screen wherein you have the sheet of A2. Now I need to change it to A4. So to do that, so first I will go for the lower left corner wherein you have sheet 1. Just right click on the mouse button and click on sheet setup, and in the background sheet you have default is A2, you select for A4. Then you want to show the background. I don't want to show the background, so I will say disabled it and say OK. Now the sheet will go into strings from A2 to A4. Now the display is still set for A2, so you fit it to set it for A4 now. Once you do that, now I need to go for writing the question. So to do that, before that, first I will go for sketching and make sure in IntelliSketch endpoint, intersection and horizontal or vertical is enabled and all other options is disabled. So now I need to write the text. So to write the question, go to text. So here by default you have solid ISO. Now you select Times New Roman and you take the font size for writing the question is for 4. Then enter. Then you start typing the text. A frustum of a square pyramid, a frustum of a square pyramid has its base 40 mm sides, top 16 mm sides, top 60 mm sides and height 60 mm. Its axis is vertical and a side of its base is parallel to VP. Draw the projections of the frustum and show the development of the lateral surfaces of it. So once you do that, you just right click. Now you go to move command, select this and take it out and bring it here. Now you go to zoom window. Now we need to solve the problem. A square pyramid of side of base of 40 mm side. So first I will go for a line command and take the line width as 0.05. Okay. And take some arbitrary point and take 40 mm, angle is 0, then you take 40, angle is 90, then you take 40, angle is 180, then you take 40, angle is minus 90. So then you have top side. So first I will go for a line command, I will draw a diagonals. Then I will take the XY line, okay, and you take offset 60 mm, offset you take 60 mm, so you select this, okay. Now I need to go for the projection, so here I will consider this as the base, I will take text I will take 3. Okay, I will say A, B, C, D. Okay, so we have move, select this and bring it nearer like this. Then you have C, then you have D. This is the base. Okay, so go to line, take the endpoint of this, then you take the endpoint of this. So go to trim these two and these two. So then go to line, take a intersection of this and draw a vertical line. Then you want to write 16 mm side. Again you go to line, take arbitrary point, take 16, angle is 0, then 16, angle is 90, then 16, angle is 180, then 16, angle is 270 or minus 90, whichever way you can do it. Then go to line, take endpoint of this to endpoint of this, and take endpoint of this to endpoint of this. Now you go for move, don't copy, select all these 4 lines. Okay, take the intersection of this to intersection of these two. So this is the top surface. So you just go to select and you delete this. Now you consider a line from the endpoint or intersection till here, then from here also you take this. Then go to trim between these two. So you have a line, take endpoint of this to endpoint, and similarly from here to here, and then you take it on this side, similarly on this side also, which is the XY line. Now you go to select these 4 lines. Okay, then later on we'll do that. Okay, now you go to move, select this entire drawing, bring it down. Okay, so that we will have some extra lines here. So go to trim corner between this line and this line, similarly from here to here. So we have, suppose if I don't consider this frustum, then what would have happened? So you got a square pyramid. This is the, if you are having only the base, then this is the pyramid. Since the section plane is cutting at a height of 60 mm, that is the frustum. That is a section plane. What is a frustum? A frustum wherein a section plane is parallel to HP and perpendicular to VP is called as a frustum. Now I need to show the dimensions. So before that, I will go for a split this line till here, then you split this line till here. Now you go to select this line, this and this and this. Okay, you make that it as 0.5. Okay, similarly here you take these 4 and you take these 4. Okay, and make it as 0.5. Okay, then go to split this line till here, and you split this line till here, split this line till here, then you split this line till here. Go to select. Okay, make this as 0.5. Okay, now once you do that, now we need to go for the naming of the bottom surface. Here in the front view, you make this as A dash, and here it is B dash, then here it is C dash, then here it is D dash, then here it is O1 dash. Okay, then here it is capital X, and here it is BP, and then HP, then here it is Y. Okay, then go to move, take X, here it is VP, HP, A dash, D dash, O1 dash, C dash Y. Go to select, go to select, and these two, make it 0.13. Okay. Now I need to name them here. Similarly, in the front view, I want this. So here, I will go to text. I will say 1 dash, and here it is 2 dash. Then we have 3 dash in bracket. Then you have 4 dash in bracket. So which are all the points here? It is 1, here it is 2, here it is 3, here it is 4, and here it is O. Put the caps lock of type O and O1 in bracket. Then go to zoom window, then go to more, select 1 dash, then 2 dash, then 3 dash. Of course, we need to find the true length, let us see, 4 dash. Okay. Similarly, on this side, go to fit, come to the top, that is the top view, and go to more, 1, 2, 3, and then 4. Here it is O1, here it is O. Okay. Now I need to name them here also. Here you take text, type O dash. Okay. Then go to fit, then go to move, select this, and you keep it O dash. Now once you do that, now I need to go for the finding of the true length. Why I have to find the true length? Because OA, OB, OC and OD, none of these slant edges, that is O dash A dash, O dash B dash, O dash C dash and O dash D dash. So here in the top view, if this line is parallel, then you got the true length. Since these OA, OB, OC and OD are inclined to VP, so this line will not be in true length. So I need to find the true length. So how to find the true length? I need to make one of these slant edges parallel to VP. So to do that, I will go for a line command, draw a line, a horizontal line, and then I will go for a circle command, take endpoint of this, okay, to the endpoint of this. If you do like this, then what happens? All the vertex will going to passes through the same center point, and all vertex will passes through on this. All the vertex points are on the circumference of the circle. Therefore, if you find for any one of the slant edges, if you find the true length, then automatically all these slant edges will have the same true length. So applying that, so now trim, I will trim this portion. Okay. Then once I get this, that is I am finding out the true length of the slant edge B. Then what OB? Then what happens? This B dash which was here will move to this point here. Okay. So then go to trim this line. So this will go to become B1 dash. You need not have to name them, but at least you should know how to find the true length. So then we go to line command, draw a line from endpoint of this to endpoint of this. So this is actually the true length of the slanted OB. This is the true length of the slanted not only to OB, it is also for OA, OC and OD. So I will take this point till here. So this is 2 dash here. Now 1 dash, 2 dash, 3 dash, 4 dash are the section plane which is parallel to HP. So all these slant edges will going to have the same true length. So you draw a projector from here and then go to trim and trim this line. Similarly, now I need to go for the dimensioning. So to do that, go to style, select ISO, modify, come down to general, take black, okay, then go to text, select Times New Roman, select Times New Roman, Okay, and the font size is 3. Go to lines and coordinates, take it 0.1. Okay, then apply. So now we go for distance between, take endpoint of this to endpoint of this. So you're going to get it as 41.57. Again go to distance between, select this point, endpoint to this endpoint. So you are going to get it as 193 or 103.92. Correct? Yes. So you go to this and you come down to where exactly you can see that 103.86 is there here. So here it is 41.54. Why this difference, that we need to check. So maybe fit. So here or are taken properly, and this height, let us see what is the height of this. Go to text, dimension, distance between these two. Okay, it is 60. Okay, then you take square, so select the square symbol here. Okay, then you take this line which is square 40, and then you take these two which is square 60. Okay, one should do that. Now we go for the dimension. So take this, so go to distance between, select this endpoint to this endpoint, 41.57. then it might be the mistake of that. So here you go to this, you clear it and say okay. Now you are going to get 41.57, and then again go to move, select this and you keep it out, and similarly you select this and you keep it out. Okay, now you go to fit, come down to zoom window, then you go to distance between, select endpoint of this to endpoint of this, you take 103.92. Yes, correct. So once you do that, you go to fit. Now I need to consider this as the point. So to do that, I will go for a line. First I will going to draw one horizontal line of any length and go to circle, take endpoint of this, take 103.92 as the radius, go to tab and type 103.92. Then I need to consider since it's the true length, that is 40 mm side, so go to arc by center point, take this intersection, the radius is 40, sweep angle is 10 degrees, you take this and you keep it on this curve. Then again go to arc by center point, take the intersection point of this, radius is 40, sweep angle is 10 degrees, and you click on this. Similarly again take the center point, radius is 40, sweep angle is 10 degrees, you take this line now. Similarly take the intersection point of this, radius is 40, sweep angle is 10 degrees, and you click it. Now you go to line command, draw a line from end point to this intersection to this intersection to this end point. Similarly line, take the end point of this to intersection of this to end of this to intersection of this to intersection, then you find the end point to this intersection. Now then go to trim this line till here and this line till here and this line till here, and go to select this and you remove this. Now you take the radius of 41.57, so go to circle, take end point of this, take the radius as 41.57. Then you go to trim this entire thing, you will going to get this. Now you go to zoom window. So here go to line, take endpoint to this intersection to this intersection to this intersection to this intersection. Okay, once you do that, now you go to fit and you split this now. Go to split this line till here, then you 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 split this line till here. Now you go to select by holding the shift key, select this line, this line, this line and this line. Take this base, okay. Then you select this line 2, 3, 4, 5 and go to 0.5. Okay. Once you do that, now we will go for the text. Type capital A, B, C, D, A, then 1, 2, 3, 4 and then 1. Okay. Now you go to fit. Similarly, come down to this. Take move D, C. Okay. Then go to fit. Similarly, on this side, take move B, then A, then take 1. Similarly here 2, 3, 4, okay, and 1. Okay. Now you go to select between these two, that is the dimension which is 40, and you take between these two which will be 16. Okay. And you take the dimension of this line which will be 41.57, and again from here to this it will be 103.92. Then go to move, select this line and take it inside. So this is how you will be able to create the drawing on this particular point. And you go to select this and you break this strip. Now you go to this axis line and make this as the axis line, and you go to move, select this entire drawing, that is this one, the solution, and now you go to move, go to text, here you type development. So this is how you will be able to create the drawing on the frustum of a square pyramid by using the Solid software. Thank you.